Hello and hi. Uh, I'll be presenting about the Python code that I generated for my project, that is predicting of complicated malaria. So at first point here, I imported the libraries, and these are the libraries for Python that are going to be working out for me. And the second point here, I imported my data set, which is called malaria I underscore UG, which is in CSV. I try to display the rows, the number of columns in a shape, which I get 189 rows and 17 attributes, which are the columns. I preferred this because it's for study reasons. Maybe for the real project, it's going to be much more bigger than this. This is my table. This is my data set displaying all the information here. Though I have nulls here, I'll be cleaning data at the base there. This is description of my data set. The first, when it comes to cleaning now here, I'll first try out the indicator here. I try to find out how many counts does each of the items repeat, where I got 6 values of count. The first value here is the malaria prevalence according to the RTD. I also have another one of tested using RTD, which is unweighted, using the microscope, tested using microscope, which is unweighted. I also tried out the surveyor, and I wanted to find out how many years was this data got. I got 3 years, which is 2009, 2014, and 2016. Okay, in the survey, surveyor, survey ID, I also wanted to find out, yes, which IDs were used per year, where I have in 2019, 2014, and then 2016. Okay, I dropped off some columns, or some, well, yes, some null values within, sorry, null columns within my data sets, and those are the by variable ID, and then the is total. These columns didn't seem to be doing of any relevance to my project here or my data set here. Visualizing of my data set, I happen to have visualized, for the reason of study, I visualized the survey ID according to, or using the use surveyor, the survey ID per year, which was in 2009, 12, 14, and 16. Here is the the shape, which or the figure, which is for this visualization. When it comes to the distribution using the box plot, I first happen to have dropped whatever nulls that are in my data set. At this point, I perform another sort of display of the data set after dropping. I also normalize the numerical data by pandas. Pandas is actually so unbiased when you try to normalize your data using it. Here I'm normalizing six columns, sorry, 5 columns, which is the value, the denominator, unweighted, C low, and then C high. I named out this because these are the columns that have the data that I am going to be focusing on. All right, after the normalization I've used here is for the standard deviation here. So another normalization I've tried to compare to is by the mean max normalization, where I can see, yes, we can all see that this data here, this normalization is different, but when you look at why I can prefer the min max, it's because it actually scales data between 0 and 1, which commonly or usually helps people to understand the data easily. But for this other standard deviation, yeah, this one is also good because it calculates variability of data, which isn't dependent on maybe the size, or perhaps maybe we can say the magnitude, or we can simply say data of large means, preferably, if it can work out for that. So those are the two normalizations I tried. Plotting of the categorical variables here, I have plotted using the same 5 columns that or attributes that have just been normalizing up here, and they are here. I've used I've used this graph, and then I've used the dots and also used the lines here. So at this point here, I also continue to use another sort of visualization of my data here. This one I visualize using the lines in Brave, and I've just expanded this to actually explain. But I've used the same 5 attributes with data which I said maybe value has the highest of 100, denominator weighted has up to 500. Yes, that's why. Okay, I have not just guessed this out, but I have used what is a part of the data. Now the box plot, here I have used still the normalized data, which is from up there, and you can see my box plot, box plot. I have the precision, the weighted, the unweighted, the C-low, and the C-high, all in the box plot. Now with the feature comparison, I have taken the C-low and the C-high, and yes, if you look at the line that I have even drawn, which is drawn across, you see that this the prediction here, it looks not to be, because I have it's not overfitted, or neither is it underfitted. It's sort of unbiased, because I have the two which are falling up, and then I have the two which are falling what below the line. When it comes to this point, I actually try to plot a pair plot graph, which I can see it, or we can see it here. Performing the correlation here, yes, the correlations are here coded with different colors. The negatives which are so low are coded different. Those ones which are so high are also coded different. I still using those 5 attributes which I normalized up there. Here I'm checking out again my data on the data set. So when I come to the cleansing of data, trying to split my data, I split my data into the train and then the test data, the train and test data set here. At this point here, I'm actually going to be categorizing. I said, okay, let me first find out or putting this data into categories, and I'm going to use the bins of from 0 point maybe 0 or 0.1 up to infinity. Here I'm going to give them labels, or give it labels, which labels can be any. I've chosen numbers 1 to 6. Okay, here I'm now checking out my train test split that I actually got from up here. Sorry. At this point here, I'm going to be performing the real split now. Okay, I'll say I have the test data. I am now going to call this one, I call this one the train data, I call this one the test data, and yes, this is going to take a size or test size of 20%. If I display my train data here, I can have my train data display here. I also now display the test data. I see the test data here. Trying to divide the trained data by the length of the trained data, it gives a sort of sorry here here it's supposed to give some bit of difference. Okay, I think the code just repeated itself. So this data here has to be different from the one I have not divided, or which is not divided by the length of the trained data. As we can see, this one of the test value, which is divided, and then the test value which is not divided. We can see this. At this point here, I wanted to try out on the stratified reshuffle or shovel split, but I missed out something. I'll need to work it out. It's my first time working with Python, so I'll still keep learning. I pray so. I also perform the outliers here using the IQR, that is interquartile range. I first perform, I look at two QRs, which is Q1 and Q3. Q1 has up to 25%, and then represented by 75% for Q3. So for IQR, I'll minus 1 from 3, and when I'm getting the IQR of my data set, or okay, the IQR of 1, I will now say, okay, for Q1 minus 1.5, and then you have to multiply the what, the IQR, which has, if it is -1, then yes, we are going to be looking at. For the Q3, I will add 1.5 times the IQR, and there are two basic outputs. They either can be negative and can be a positive. So when we analyze on our data set here, okay, I think it's going to be down. When we run this, and we're going to look at the results in the next okay. So here I'm also going to be using the outlier of isolation forest, where when I isolate, I am actually going to find the negatives, the positives, and so forth. So this isolation, yes, is going to predict for us, or there's going to be prediction using wherever we see the negatives. I think that's where we are going to be looking and having our focus. So when we get to look at the isolation or the prediction, sorry, using the elliptic envelope, you see that where I found the positives in the isolation, I also now have the negatives at that point. Where I had the negatives, I now have the positives. As you can see here, I had negatives here, and now here I have positives using what? Using the elliptic envelope. Yes, using the local outlier factor, this one also gives us the best sort of prediction, where we're just going to we're going to be focusing on our negatives here within the data set, and that's going to be our focus of prediction. In hyperparameter tuning, I'll be using the random forest, and this random forest, yes, I'm using my train data and the test data at the same time, where I'll be able to have a prediction, and this prediction will come from the C-high values, which are divided and then multiplied by 100%. I thank you for listening.